My final example shows the application of implicit FEA, where it was used very successfully in designing a machine that will cold roll a circular pipe into a cross section. We have used the implicit FEA to do the concept analysis, making sure that we don't exceed the elongations in the material. Stresses were acceptable. We tested the concept of invoking 4 buckle points through a roller system. We continue to press on the mating surfaces until full buckle occurs, and the profile then finds the mandrel on the inside. Sufficient pressure was added, and on the final picture just before the cross-section photo, you can see that the surfaces were lifted a little bit, and we could see how much springback will occur. In this animation you can see the results of the implicit FEA. The flat surfaces moving towards the mandrel on the inside is actually the cross-section of the rollers as this profile will run through it. At the end of this animation you will see the roller surfaces moving away from the actual profile, and you will see that the residual stresses creates some form of springback in the component. This final animation in the implicit FEA example shows the rollers as rigid surfaces and a section moving through them, inducing the deformed shape that we require. These forces were extracted and applied to the actual machine to make sure that we have sufficient stiffness in our structure to obtain the rolling tolerances. Here you can see the CAD model for the rolling machine with its single stage rollers. Finally, the actual machine that was built and producing these samples that you can see from the round profile to the crossed profile. That then concludes my contribution. I'm going to give you back to Cyprien and Piotr, and hope that you enjoy the rest of this webinar.